These are the notes for section 7.2, similar polygons. The objectives are I will be able to identify similar figures and I will be able to solve problems involving scale factor. To start off, similar polygons are polygons that have corresponding angles that are congruent and corresponding sides that are proportional. Similar polygons have the same shape but may have different sizes. And our symbol for similarity is a tilde. So similar polygons aren't too different from congruent polygons. We have one thing that's in common. They have congruent angles. So the corresponding angles are congruent. One thing that is different is that the corresponding sides are proportional. Whereas congruent polygons had congruent sides. And the symbol for similarity is the tilde, and the symbol for congruent, of course, is the equal sign with the tilde on top. So that's a quick rundown of the things that we should see that are in common or pretty similar between the two, similar and congruent. Here are some examples. I'd like you to try number 1 on your own, and to assist you with number 1, we're going to take a look at number 2. Now the directions say list the pairs of congruent angles and write the statement of proportionality. So the congruent angles are pretty easy to write. Again, we're not looking at the picture like we were. We shouldn't have been looking at the picture if we were given words with congruent polygons or congruent triangles. We're given these letters, and remember the corresponding letters have to be congruent. So the first letters are A and P. Those are the first letters. B and Q are the second letters. C and R are the third letters. And lastly, we have D and S. So the first letter, second letter, third letter, and fourth letter are all congruent. Those are us listing the congruent angles. Now we need to write the statement of proportionality. So now we're going to take the first two letters, A and B, the second two letters, B and C, the third and the fourth letters, C and D, and the first and the last letters, A and D. So we're getting all these letters from here. First and second's AB, second and third are BC, third and fourth, third and fourth are CD, first and fourth are AD. And I'm going to put them all over the corresponding letters from the other polygon. So I'm going to have PQ, the first and second, QR, the second and third, RS, the third and fourth, and lastly we'll have PS, the first and the last. So all we're doing is matching things up. So for numbers 3 and 4, these are a couple more examples. We're asked to determine whether the pair of figures is similar. And we have to justify our answers. So remember, to be similar, we need to check that the sides sorry, that's the wrong side. We're on similar. We have to have congruent angles and proportional sides. So I have to make sure the angles are the same. I'm missing an angle, so I should make sure that they add up to 180. So I do 180 minus 80 minus 60, and I get this missing angle to be 40 degrees. I do the same thing with the other triangle. 180 minus 80 minus 40, and I get 60 degrees. So I see that all the angles are the same. So I have angle A is congruent to angle R. Angle B is congruent to angle S. And angle C is congruent to angle T. Now I need to make sure that the sides are proportionate. So the side between 60 and 80 is 5.2, and we have 3.9 over it. So we have 5.2 over 3.9. Another side here, the side between 80 and 40, is 7 over 5.25. And lastly, I have 8 over 6. Those are the sides between 60 and 40 degrees. Remember how we talked a lot about included angles with congruent triangles? That same idea is very important with similar triangles or similar polygons. Now we need to make sure that these are equivalent. So we get 1.333. Again, the same thing. So they're all equal. Because they're all equal, this means the sides are in proportion. So whenever I take a look, I've met both of my qualifications here. I have all congruent angles and my sides are proportional. So that means the triangles are similar. So if I want to write a similarity statement, I would just say triangle ABC is similar to triangle RST. Notice all my letters are in the same order. The first, second, and third, the first, second, and third. The next example is actually easier because we will determine that the triangles aren't similar. We take 180 minus our two angles, 40 and 104, and we get 36 degrees. And we're going to do the same thing with the other triangle to figure out what its missing angle is. So 46 minus 40, and we get 94. So we can say right away the triangles are not similar because the angles are not congruent. So we follow the directions. We determined whether they were similar, they're not, and we justified our answer. So let's continue to move on to the second page. This talks about scale factor. Scale factor has to do a lot with proportionality. They're very similar. It says they are the ratio of the lengths of two corresponding sides of similar figures. So for our examples, we're told each pair of figures is similar. Find the scale factor of each pair. So what we have to do is take a look at the certain sides we have. This is between one angle mark and two angle marks. Do you see that? J has 1, K has 2. Q has 1, R has 2, so I know that 20 over 12 should be my scale factor. Remember, whenever we talked about proportions in the last section, we said that we always had to reduce it. So if I do alpha, y equals enter, 20 over 12, I get 5 to 3. And you could see that you could do this with any of the four sides. We would always get 5 to 3. So the side between 1 and 4 is 25 over 15. We could do that with all the other sides. So that's also 24. That's the side between 4 and 3. 24 over 14.4. And the last side is 15 and 9. All of those tell me that they all reduce to or simplify to 5 over 3. Let's take a look at the other example. We'll do this one quicker. So no angle marks to one angle mark is 12. No angle marks to one angle mark is 18. When I reduce that, it becomes 2 to 3. So these are the answers to the scale factor. These examples have us solve for the scale factor. So it says find the scale factor, x and y. So first I need to figure out which sides are actually proportional that we have knowns for. So the no angle mark to the one angle mark is given on both triangles. So the scale factor is 8 over 12. When I simplify that, they're both divisible by 4. That's 2 to 3. So the scale factor is 2 to 3. Now what I need to do is solve for x and y. So I see the side that goes 2 is x over 9. I know x over 9 is 2 over 3. So just like we did in our last section on proportions, we cross multiply. 18 is equal to 3x. We get x is equal to 6. And for y, we see that we have 10 over y is equal to 2 over 3. Again, we just cross multiply. 2y is equal to 30. We divide by 2, we get y is 15. I'll show you how to do number 9 also. So again, we're looking for the side that we have two known values for. That would be the side between one angle mark and 4 angle marks. So the scale factor is 12 over 18. When I reduce that, they're both divisible by 6. That's 2 to 3. That's the scale factor. I need to solve for x and y. I'm just going to solve for y. So we get 2 over 3 is equal to y plus 1 over 24. When I cross multiply, I get 3 times the quantity of y plus 1 equals 2 times 24. That's going to be, when I distribute, 3y plus 3 is equal to 48. And I need to subtract 3. Continue it over here, 3y is equal to 45. And dividing by 3, I get y is 15. X is much easier to solve. What I'd like you to do is finish these. I'd like you to find x for number 8 and to try numbers 9 and 10. We're also given some word problems. It says an architect prepared a 12-inch model of a skyscraper to look at an actual 1,100-foot building. What is the scale factor? So there's that word, what is, the words. What is the scale factor of the model to the actual? So the model needs to be on top in our numerator. The actual needs to be in the bottom or on our denominator. So we're given this right here. So the height of the model was 12 inches. The height of the actual is 1,100 feet. I need to convert 1,100 feet into inches. So how many inches are in a foot, or how many feet are in an inch? We should know that 12 inches are in 1 foot. So what you need to do is just multiply 1,100 times 12. We get 13,200. And we have 12 in the numerator. Now I just divide it. So alpha y equals enter 12 over, one thing I can do is, oops, that didn't work, 13200. We get 1 over 1,100. Which makes sense because we started with 12 in the numerator and we're just dividing by 12. Let's go on to the third page. We're going to do numbers 13 and 14. You should try number 12 on your own. Number 13 says triangle ABC is similar to triangle XYZ with a scale factor of 2 to 3. If the lengths of the sides of ABC are 6, 8, and 10, what are the lengths of triangle XYZ? Maybe it would be helpful if I drew a picture. A, B, and C. Well, I have like 6, 8, and 10. And the scale factor is 2 to 3. When the scale factor is less than 1, that means it's going to be a smaller triangle. So I'm going to make a smaller triangle, X, Y, and Z. It's going to be smaller because I'm going to take a length, 6, and I'm going to multiply it by the scale factor, 2/3. I take 8, I multiply it by 2/3. And 10, and I multiply it by 2/3. All the sides are in proportion. Remember, that's what happens with similar polygons. So I just do 6 times alpha y equals enter, 2 divided by 3. I get 4. 8 times 8 times alpha y equals enter, 2 divided by 3, 16 over 3, and 10 so my answers are 4, 16 over 3, and 20 over 3. So if I was making something similar, it would just be this. So I found the lengths of the sides of triangle XYZ. The last one, number 14, says the scale on the map of New Mexico is 2 centimeters equals 160 miles. The distance across New Mexico from east to west through Albuquerque is 4.1 centimeters. So our question asks us, how long would it take to drive across New Mexico at an average speed of 60 miles per hour? One thing that you should remember, probably from Algebra 1, is velocity is equal to distance over time. We need to solve for time. That's how long, right? How long is time? We have velocity. Velocity is 60 miles per hour. And we need to find the distance. So in order to find the distance, we're given 4.1 centimeters. And we are told that 2 centimeters is equal to 160 miles. So what I can do is I can just put 2 over 160. That's my scale factor. So in my calculator, what I'm going to do is alpha y equals enter. I'm going to take 4.1 times 160, and I'm going to divide it by 2. Last time we didn't have to put a fraction when we converted units because there was a 1 in the denominator. So this is equal to 328 miles. So the centimeters will go away. So that's my distance. So it's equal to, change colors, 328 miles. So to solve for t, I know that t is equal to d over v. There's a trick in Algebra 1, we'll be talking about it later on in the year a lot with right triangles, where we can replace those two. So time is equal to distance, 328 miles, over velocity, 60 miles per hour. So the miles go away and the hours are going to go to the top. So in our calculator, we're going to type 328 divided by 60. And we get this number, 5.46 repeating. So it's about 5.47 hours. A lot of times it's difficult to express that. How long is 0.47 hours? So what we can do is we can convert this. If we subtract 5, we have that many hours, right? So if I take the 0.46 repeating hours, and I can convert that to minutes. So you should know there are 60 minutes in 1 hour. So it's that number times 60. And that's 28 minutes. So to give you a more precise answer, this would be 5 hours and 28 minutes. I expect a lot of you will struggle with this last problem because there's a whole lot going on there. These are the types of problems that you might have seen if you're already in chemistry, where we have to do a lot of unit conversion. But hopefully the concept of scale factor is more familiar to you, because that was one of the objectives. And if you have any questions, please come to class prepared with them.